going to set up an NFS server in Linux and then mount it as a persistent volume in my Kubernetes Spring Boot application. So I have a very simple controller that has a counter method, which is counting up each time the method's used and saving the file in a volume in Kubernetes each time the file is accessed. So the effect of that is we can just count up and we have a file which is saving the number. So we have persistent storage. But the problem with that is, or the problem with the version we're using at the minute, is we're using a host path volume, so it's mounted on the node, which is not ideal because if we were to have multiple replicas of our pod, they may be distributed across different nodes and they wouldn't share the same file. So the better way to do it is with a persistent volume. Now in the Kubernetes documentation there's lots of different persistent volume types to choose from, but I'm going to go with NFS, network file storage, which is something which is very easy to set up on a Linux server. So to install an NFS server, you need a spare machine running Linux, or you could use a virtual machine. I've got a server rack behind me and this is the console to my Linux server. If I do ifconfig, I can see that it's running on 192.168.1.122. To install an NFS, you do sudo apt install NFS kernel server. The instructions may be a little bit different depending on which version of Linux you're using, but I'm using Ubuntu. If you're using a different version, you may want to check the documentation for how to install NFS, but I've already got it installed. So I'll do systemctl status NFS kernel server, and we can see that it's active. It does say exited, but we can check the processes. So do ps aux and pipe it to grep nfsd, and we can see that we have 8 processes running, so we know the NFS server is working. And then to configure NFS, we edit the file etc exports, and we can define our NFS share folders here. So what I'm saying here is I want to export a file, exports NFS share, and I want that to be shared to the subnet 192.168.1, and there's the subnet mask there, so anyone from that IP address range can access our NFS share, and my machine that I'm running Docker Desktop on is on that subnet. And then we have a few different options. We need to use the insecure option because NFS has a standard range of ports that it accepts connections from, and Kubernetes is outside that range. So that's my exports NFS share. If I then go make a directory exports NFS share, which I've already made. So if we look in the exports NFS share folder, that's empty at the minute. The final thing I could do to make sure the NFS share is being exported is show mount exports and the IP address of this machine, and we can see that exports NFS share is being exported. Now the other thing I need to do on Ubuntu is configure the firewall to let things come in. So to do that I would do sudo ufw, which is uncomplicated firewall, which is the firewall I'm using on my version of Ubuntu server, and then I would say allow from 192.168.1.0/24. So that is saying allow incoming connections from the subnet and the subnet mask there. I've already done that, so if I do sudo ufw status, I can see I'm allowing all incoming connections from that address range. Now obviously in production we would probably want to specify ports and specify individual hosts that are allowed to come in, but I'm just allowing everything. This is an internal network, nothing can see this from the outside. I'm protected by my router firewall, so that's okay for me. So that's how to set up an NFS server. Now it's worth at this stage making sure the NFS server is working, because if we have problems in our volume configuration in Kubernetes, it would be useful to know that the NFS server is working and that the problems with the configuration and not the NFS server itself. So I have a second Linux machine here. We can see that's running 192.168.165, and I've made a directory mount test NFS. Now on this machine, to install the NFS client, I'll do sudo apt install NFS common, and that would install the NFS client, but I've already done that. But now I could do show mount exports and the address of the server. And we can see that we have exports NFS share on the server. So now I can do mount the address of the server exports NFS share as it's defined there, and our local directory mount test NFS. I need to do that as sudo. Now if I do dfh, I can see that I have the NFS share mounted on the server in the client directory mount test NFS. So now I have the client here and the server here. So I'm going to cat test to mount test NFS my file.txt, echo test, and then if I get the directory, see my file in there and my file is on the server, and if I cat we can see test, so I've written a file onto the server there. So the NFS server is working. We've checked that it's working with a client, so we're ready to mount it into our Kubernetes volume. One thing I need to do is cat proc mounts and grep that so it filters a line to NFS, and we can see which version of NFS we're using. So I'm using NFS 4, we need to remember that. Okay, so I'm going to go into my YAML now, and I'm going to define the persistent volume. It has to be declared separately, and the persistent volume is not in a namespace. It's just provisioned outside of any namespaces. And the YAML looks like this. So we have API version v1, kind persistent volume. We're going to call it MSHW PV. Type NFS, and then we have various parameters for it there. We need to specify NFS version 4 that we got from the Linux server, and then the path is exports NFS share. That's the path as it is on the server, and this server IP address is there. Now to get access to this, we make a persistent volume claim that goes in the namespace, and the persistent volume claim will match to a persistent volume depending on its properties. So a claim is really a request for a volume. So I'm going to put it above my deployment, and it looks like this. So we have a persistent volume claim. I'm going to call it MSHW PVC. It's going in the namespace with the deployment, and we want it to match type NFS, which matches the type NFS that we've specified there. And then we have volume mode, file system, storage class name, NFS, access modes, rewrite many, and storage 1 GB. That should match all the things that we've defined in here. So when we mount a persistent volume claim in a deployment, it will try and find us a persistent volume that matches those parameters. So now I just need to adjust my volume section and change MSHW volume. Instead of being a host path, I want to specify a persistent volume claim, and claim name is MSHW PVC. And that should now be configured to use our NFS server as the volume. So I'm just going to redeploy the YAML. I'm in the right place. So kubectl apply f mshw YAML, and we can see that we've created a persistent volume, we've created a persistent volume claim, and we've configured our deployment. Everything else is unchanged. Now I could do kubectl get pv, and we can see we have our PV there, and we need to check that the status is bound, which means it's bound to a claim. So now if I do kubectl get pvc, persistent volume claim, remember that is in the namespace, that is also bound to MSHW PV. I just check that our pod is running. The pod's running, so we should be good to go. So mshw.counter 1, 2, 3, that appears to be working. And now if I scale down my deployment to 0 and back up to 1, that's just restarting, the counter carries on from where it is. But the thing is, now the counter is stored on our NFS server. So I'm going to pull up the console of our NFS server. And if I cat counter, we have in there 9. And if I reload, 14. So now our NFS server, the counter file is being kept on a separate server. So that's how we can mount an external folder in Kubernetes, and we can persist data in there. If other nodes are pointing at the same NFS server, we know they're all pointing at the same data. They're not using a directory on the pod or a directory on the node. They're using a completely separate volume. So that's how we configure persistent volumes in Kubernetes. So in the next video, we're going to be building another microservice, and we're going to have a look at how we can get microservices to talk to each other, which is the whole point of microservices really. If you're making a microservice application, it would be built of multiple microservices. So that's it for now. Thanks for watching.